Okay, so hopefully you have already seen the video on non-renewables, and we're going to move forward and talk about renewables. So if you recall, non-renewable fuels or non-renewables are fuels that are not renewable on a human timescale. So what are renewable fuels or renewables? Well, they are produced by sources that are renewable on a human timescale. Okay, so again, human timescale being on the order of a few decades. Most renewables renew themselves much more quickly than a few decades, but it's important to distinguish between the ones. We have to have a cutoff somewhere, and so a few decades is generally understood. Okay, so go ahead and press pause and think about some renewable energy sources. Okay, so here are the main ones that we use in the U.S. and the world. So we have solar, photovoltaics, solar in general, solar energy. So not just PV, but solar thermal, so heating up water, using sunlight to heat up buildings and so forth. But solar PV is a really big one, rapidly emerging field. Wind is a major source. Again, these aren't the dominant sources, but these are important. Biomass is one that's really big. So biomass is anything that's living or recently living. So it could be trees, or corn ethanol is a really big one in the U.S. and other parts of the world. I mean, there's sugarcane ethanol. There's biodiesel. There's all kinds of biomass. So anything that is living or recently living. And then hydroelectric's a major one. That's actually the biggest source of renewable electricity in the world and in the United States. So, electricity from running water. Then there's some others like geothermal, wave, and tidal. Geothermal is kind of big, but not real big. Wave and tidal are at this point really, really small. Okay, so that's our renewables. So they are renewable on a human timescale. So of course, solar and wind, I mean, that's constantly renewing itself. Hydroelectric, I mean, as long as the water's flowing, the energy is constantly renewing itself. Now, biomass is where you get into this, it could take like, a crop of corn, maybe it takes 5, 6 months to grow. A tree, maybe it takes 20, 30 years, or you have switchgrass, other forms of ethanol, biodiesel, and so forth. So they can take a little bit longer, but they do renew themselves. Okay, so let's look at two important, what I think are pretty important distinctions. Some people don't make this distinction, but we have carbon-free and carbon neutral. So if you remember from the fossil fuel discussion, one of the main byproducts of combustion, burning coal, oil, and natural gas, is carbon dioxide. And so if you're paying attention, you know that this is a big issue right now with climate change and everything. So we're worried about our carbon emissions. And so we have certain energy sources that are carbon free and certain that are carbon neutral. Okay. Um, and now there's a subtle difference here. So carbon free just means that there's no carbon emitted when you generate the energy. So solar photovoltaic, so you could stand right next to the solar panel. This is not emitting anything. There's no CO2, there's no nitrogen oxides, there's nothing coming off of this except for heat. Same with wind, same with hydro, same with geothermal, same with wave, and same with tidal. So all of these are carbon-free sources, okay? Now carbon neutral, on the other hand, means that no net carbon is emitted. And I'll show you what I mean by this. So if you think about um, how how vegetation grows, so what it takes to grow. So you have a tree, right? So a tree, in order for the tree to grow, or corn, or whatever, it has to take in CO2, right? So basic photosynthesis, right? So you take sunlight and carbon dioxide, and there you go, you're creating your biomass. Take some water and so forth, okay? So it pulls in CO2. Now here's the thing, is that when you actually burn your biomass, so when you extract the energy out of the biomass, so when you take a tree and burn it, you're actually emitting CO2. When you burn corn ethanol, you're emitting CO2, okay? So it's not carbon free. It actually does emit carbon dioxide when you combust it. When you extract the energy out of it, you are emitting carbon dioxide. But the difference is that by like the laws of physics, it's not going to emit any more CO2 than it originally pulled in when it was growing. Okay, so that's an important difference, is that yes, it emits CO2, but ultimately it doesn't emit any more than it took when it was growing. Okay, so again, a lot of people don't make this distinction because effectively it ends up being carbon free anyway, because it just balances out. But I think it is important to point out that there is this difference between most renewable energy sources and biomass. And one last thing I want to mention is that the so all of these are either carbon free or carbon neutral. All fossil fuels are emitting CO2. Really important to point out that nuclear energy is considered carbon free. So this is really important. Remember, if you recall that nuclear is not combusted, it's fission, okay, so it's split. So when you split the atom to generate the nuclear energy, it releases that heat energy that then you use to generate electricity. That does not emit any carbon, so it's actually considered carbon free. So that's a really important aspect. So that's one reason why nuclear is even, people that wouldn't normally, push for a big energy source like nuclear are actually in favor of it because it does not emit any CO2 when it undergoes fission. Okay, so that's it for renewable energy. Thank you.